Hey everyone, welcome to the second lecture of Contemporary Math. Today we're going to be talking about estimating and how to estimate different values given different circumstances. To start off with, let's really quickly define what that even means, right? So an estimation is really just the process of giving an answer in an approximate form. We have in this particular course, what we're going to be talking about is 4 different types. We've got rounding, pie charts, bar graphs, and line graphs. To start off, let's talk about rounding. I'm going to keep this part short because I think we all kind of understand what rounding is. We do it all the time anyhow. So the idea of rounding is really just to say we're going to take a certain point in our number. We're going to pick a particular digit. Say we want to round to this particular digit, and everything else is going to be zeros. Everything else after that is going to be zeros. To start off with pi, we can round pi to the more commonly used 3.14, or we can take this number 13,942, and we can round it to 14,000. What we're doing here is we're saying we want to round this to the nearest thousands. So we look at the digit in this thousandth location. We look to the right. We say, all right, 9 is greater than 5. Send that to 0 and add 1 to 3. Okay? If, on the other hand, this was, say, 4 instead of 9, we would round down. We would leave the 13 as it is and set everything else equal to 0. Pretty straightforward. So next, let's talk about pie charts. To begin talking about estimating with pie charts, we first want to start by talking about what a pie chart even is. A pie chart is a visual representation of some whole that can be broken up into individual quantities. So for example, let's consider a personal budget. Personal budget might have the quantities, or the sub-quantities rather, groceries, rent, utilities, insurance, car insurance, so forth, so on. And if we were to add all of these together, they would add up to whatever the total of our budget is. So for that reason, we oftentimes, when talking about pie charts, use percentages to represent the relative quantity to the whole. So what I mean is rent might cost anywhere from 25 to 50 or 60% of your total budget. But what that actually comes out to be might be a few $100s to a few $1,000s, right? Knowing this, let's look at a particular example. Let's say we've got a company or an individual with a total budget of $536.97. And this individual is spending money on item A, B, C, and D. So it's kind of broken up, right? We've got each of these individual subparts of the total budget. Now, let's say that our individual wanted to talk about an estimation of how much C is of the total budget. So what I mean to say is, we know that C takes up 46% of the budget, but what is that value estimated out as dollars? That's what we're asking here. Similarly, A. We know A is 4% of the budget, but we want to know what that is as an estimation in dollars. That's what we're going to be answering here. To do that, the first thing we want to keep in mind is we need a round. We're going to need a round because we're going to estimate here. And in this particular case, we don't want to round our percentages. In fact, we never want to round our percentages. Because if we round our percentages, we'll end up with something that isn't an actual estimation. And I can explain that more Monday if you would like. Instead, we're not going to round these, we're going to round the budget itself. And I say, in this particular case, let's round our budget to the nearest tenth, or nearest 10th place. Okay? Doing that, we're going to say that our budget is approximately $540. Cool. With that in mind, we now want an estimate for what A is in dollars. Well, A in dollars is going to come out to be 0.04 times 540. And C is going to come out to be 0.46 times 540. Now you might be asking yourself now, well, wait a minute. This is supposed to be in terms of 46 and 4%. Where did the 0.04 come from? Where did the 0.46 come from? Well, a percentage is the representation of a relative chunk, right? If we're going to write it in a decimal value, though, we have to divide each of these by 100. So 4 divided by 100 gives us 0.04. 46 divided by 100 gives us 0.46. From here, to finish it up, we just multiply this all the way through. And that would be it. Whatever this came out to be would be the estimation for what this chunk is in dollars. Whatever this came out to be would be the estimation for what this is in dollars. Now, I've gone over this. Next, we're going to want to talk about bar graphs. So, before we start talking about estimating with bar graphs, we should first start by talking about what a bar graph even is. As you can see to my right here, a bar graph is really just a way of visually representing attributes of different items where these attributes show or share something in common, right? For example, what we've got up here on the board. We've got a set of bar graphs that compare the values with which, that compare the gross profit and employee income of some random company every 10 years. So in green, as we can see, green is going to be the employee income. And in this peachy color, we're going to have the representation for gross profit of the business. And we can see, generally the business is doing better every 10 years. Also, the employee income is doing a little bit better every couple of years. Okay, cool. Great way of visualizing this data. Now, what type of questions might we ask about this? What might we want to know using this sort of a graph? Well, we might ask what the rate of change is from 1970 to 2010. So to find that, I'm going to work it out over here and erase this definition. To find that, we would look at the change in each of these values and divide it by the change in time. So to start, in 1970, the business was making, it looks about $90,000. Okay? In 2010, it looks like it's making about $160,000 in gross profit. Okay? So if we want to know what this rate of change is, we would say, what's the difference between the gross profit in 1970 and in 2010? All right, cool. Take the difference and we're going to get that it comes out to be about 70. But let's write this all out. So we're going to have 160,000 minus 90,000. We're going to divide that by the time in between the two. So 1970, 2010. This is going to come out to be 70,000 divided by 40. Which, because I've already got it figured out here, comes out to be exactly $2,250, I should say, per year. This is about how much every year the company makes more than the previous year. So year one, we're going to make so much. The next year, we're guesstimating that we're making about $2,250 more. Well, that's an ugly number to work with. Why don't I use an estimation of this? Why don't I round it? If I were to round it, I would maybe use the 10th place. And I would say, all right, this is about $2,300 per year. This is approximately the rate of change in gross profit per year. So I'm going to write that over here. And I'm going to keep it in the same color as what we wrote gross profit with, just to make it easier to keep track of what everything is. So 2,300 per year. And I'm going to call these yearly rates, but I'll write that down in a minute. Now, really quickly, let's look at the employee income. Same game. I did the exact same thing. We're going to look at the difference between the two sets of years. So the difference in income in 1970 and 2010, we're going to divide that by the time in between. And that's going to be the rate of yearly increase, rate of yearly growth, I should say, in income. So, writing that out, 1970, the employees were making, looking at it, it looks to be about $60,000. And now looking at 2010, we can see it's clearly $75,000. Cool. So, again, we're just going to take the difference between what we earned, what the employees earned yearly, and divide that by the time in between. Do that, we're going to have 75,000 minus 60,000 divide 1970 minus 2010, which is going to come out to be 15,000 divide 40, or $375 a year, which we can approximate as $400 a year. So we're making about $400 more each year than we did the previous year. Putting that over here. I mean $400. I think I just said 4,000. 400 per year. And these are the rate of growth for both the gross profit and the employee income. So this is one way we might use a bar graph to estimate different details about data. We're going to come back to this particular example when talking about mathematical modeling. We're going to try to predict what we're going to make in 2020, in 2020. What we're going to make this year. Didn't even think about that when I made this example up. In the meantime, before we get there, I want to ask, or rather I want to point out, notice here, we generally have this sense of growth here, but it's not constant. And it's because that rate of growth isn't constant that we're estimating this. Because this is a best guess scenario, right? We're assuming that if everything goes right, every year the company is going to make $2,300 more approximately than the year before. And the employees are going to make $400 more a year than they did the previous year. So these are approximations because, again, notice this isn't strictly true always, right? Like it's not a constant linear model. But again, we're going to get to this idea of linear modeling shortly. Before we get there, we're going to talk about line graphs. So give me just a second, I'll get that going up here. So, before we start talking about estimating with line graphs, let's first really quickly review what a line graph even is. A line graph, by definition, is just another visual representation, as with all graphs. But in this case, what we're trying to do with a line graph is track the trend between two related attributes. Having said that, let's look at an example of how we might estimate things using line graphs. In particular, let's consider this line graph, which is supposed to be the line graph of the number of mentions of Tiger King on Twitter in 2020. Because who didn't like Tiger King? If you ruin it for me, I swear I will fail you. Okay, I might not fail you, but I will give you a hard time. So, looking at this graph, what we've got in our x-axis is going to be the months, right? So we start off January, February, March, April, so forth and so on. And looking at our graph, we have major ticks for each month. But then we also have minor ticks in green for the 15th day of every month. All right, cool. Now, in our y-axis, what we have is a measure of the number of mentions and tweets per million. So, for example, this is going to be 10 million, 20, 30, 40, 50 million, so forth and so on. Cool. Let's say now that we wanted to know how many mentions there were of Tiger King on April 15th. So we go to April, go straight up, it's the green tick over. Now we're going to take this on over to our y-axis. Notice when we do that, what we've got is we are at 100 million, 110 million. This looks to be halfway between 110 million and 120 million. So we would say that for April 15th, there were about 115 million mentions. All right, what about now? Let's say we wanted to know for May 7th. All right, well, May 7th is halfway in between the beginning of May and May 15th. So we're going to want to look in between the major tick, the purple tick for May, and the minor tick, the 15th of May, right? We're going to want to look somewhere in between these two ticks, approximately immediately in the middle. All right, that's about here. Now, if we were to bring this over, we would find that this comes out to be somewhere around what looks like 30 million mentions. So we would say, cool, on May 7th, there was about 30 million mentions. That's really how we would use a line graph to approximate values. It's really just going to be a case of kind of trying to eyeball what certain values are and using our references within the graph to estimate what that actual number could or should be. Having said that, let's talk about mathematical modeling now. So to wrap up this lecture, let's now talk a little bit about what mathematical modeling is. Mathematical modeling is really just the application of formulas to measurable quantities, right? So what does that mean? How does this work? What does that idea even look like in reality? Well, first we have to start by defining what a formula even is. And a formula is, as you see over here, just a symbolic relationship between two or more variables. Okay, that seems pretty straightforward, right? If I have item A and it relates to item B, what's a symbolic way I can represent that relationship? That's a formula. All right, so now measurable quantities, and how does this apply? Well, let's say, for example, we want to look at that previous problem. We want to talk about gross profit and employee income. Notice we can measure gross profit, right? And we can measure the employee income. Okay, so if I wanted to maybe model how those change over time, I could use a formula to do that. I could say, all right, let's start at 1970 and move on and predict how things are going to change in relation to that. That would be mathematical modeling applied to this particular problem. Having said that, it's not quite enough just to say, this is mathematical modeling, right? We want to know what it looks like in practice. So let's use this example. Let's say we want to predict how much money the company is going to make in gross profit in 2020. Well, our graph doesn't go out that far, but we have some data here that we might be able to use to estimate that. All right. Well, to start off with, we said every year the company makes about $2,300 a year more than it did the previous year. Okay, well, if that's the case, then let's represent time with t. And let's say 1970 is year 0. All right, fair. We want to know what the profit is, for any given year. All right, well, we said the approximate rate of growth was $2,000, $2,300, my mistake. And we're going to multiply this by time t. But notice if we do that, something hinky happens, right? Something hokey. Here, at time 0, we don't have $90,000 when we put a 0 into our equation. So we have to account for that. This is our initial condition, our initial value. All right? So when we add 90,000, my mistake, 90,000, now we have a model for what the company can expect in gross profits. What we're saying is, if we're going to add $2,300 per year to our initial starting value, then what we're saying is, this is really the profit as predicted by our model, is going to be P equal to 2,300 times the number of years that have elapsed plus 90,000. That should approximately predict what's going to happen in the future. Well, our question here was about what's going to happen in 2020, so after this, right? That means we're just going to have to put in 50 and use that as our estimation. To do that, we've got 2,300 times, let me use other colors. Times, well, 2020 would be 50 years after 1970, so times 50 plus 90,000. And from here, we're just going to do arithmetic. We're going to multiply the two quantities, and then we're going to take the sum of the two quantities, which I actually have written out here, I think. Do I? Oh, I do not. Well, since I don't have a calculator with me right now, I'm going to just leave this on the board as an exercise for y'all to try. Think of it like a question of the week. You can come to me and have your math double checked. Having said that, I want y'all as a kind of a extra assignment for some extra credit. For extra credit, yes. I want y'all to try to come up with a model for the employee income using the same notion. Notice what you're going to have to keep in mind is the rate of growth and what that initial condition is, right? And having said all of that, I will let y'all go. If you have any questions, by all means, feel free to ask. Shoot me an email, set up a Zoom meeting, whatever you need to do. Have a good one, guys.